Hello, good morning to everyone. Um, as we know that we are remaining three chapters, that is shaping machine, slaughter machine, planner machine, broaching machine. So today I'm going to discuss about the shaping machine. So throughout this video, we are going to cover about the what are the shaping machine, what are the different operations that can be formed on the shaping machine, how the shaping machine works, what are the quick return mechanism. These all things we are going to discuss in this today videos. So the content of principle of operation of shaping machine, what are the different types of shapers, construction of shaper, what are the different mechanisms that we can use or we are using in the shaping machine, shaper operations, how to specify the shaper machine, and introduction to planner. So it is principal operation of shaping machine. So it is the body of shaping machine. We all know that this ram reciprocates in horizontal direction and this workpiece will move from in this direction. So during the travel of this ram, the tool will touch the workpiece and remove some material from the surface of the workpiece. So shaper machine is used for generating a flat surface. Single point tool reciprocate on the job. It is a single point. Drilling, milling cutters are the multi-cut. It is a single point tool. Job is fed across the tool and tool is moved downward after completion of cross feed. It means whenever the one complete stroke is over, tool moves downward, or we can say that workpiece moves upward. Okay, so for next surface we'll cut down, again the next surface workpiece move upward with some feed or depth of cut. So basically the length of stroke and position of stroke can be changed. So what are the different stroke that required that can be changed, that can be vital. Now the types of shaper. That is the one type of shaping machine using horizontal shaper. It means name is horizontal. Push cut type, it means cutting action in outward stroke. Pull type cut, it means cutting action in inward stroke. It means whenever this stroke comes from the outward, cutting will take place. That is known as a push cut. Or pull type, it means cutting take place in inward stroke during the inward motion of stroke. With a vertical shaper, ram is a vertical. It means ram have to slide this in this direction. It is known as a slaughter machine. It is generally used for creating a slot. Mechanical shaper, ram drive is mechanical, or hydraulic shaper if ram drive is hydraulic. So this is the construction of shaper machine. Overall conventional shaper machine, it is known as the ram. That is a ram locking nut. If you remove this, if you put this nut on, it is ram is locked. That is tool slide. Here we can mount a tool. That is a hand wheel for vertical tool slide. You can slide the vertical in this direction for the tool by using this hand wheel. Here there is a screw is located for tool. If you insert the tool in this direction and you tighten the screw, that will be holding purpose. That is known as a vise. In this vise your workpiece will be mounted. That is known as a cross rail. Here it is a table. This cross rail that can be moved in this direction or in this direction. That is known as a handle for cross wheel. Okay, so these are some basic components of the shaper machine. Now look at the clapper box. It is the most important question why we are using the clapper box. Read the name carefully. That is known as the clapper box. We all know that during a cutting stroke, material will remove, and during a return stroke there is no removal of material. So the clapper box is provided in a such way that during a cutting stroke it removes the material, and during a return stroke it is not creating any impact on our workpiece surface during a return stroke. So that's why during a return stroke, if the tool touches the workpiece, it is tilted to some angle with the use of clapper box. So clapper box helps to avoid damage to machine surface during the return stroke of tool. So it is most commonly used in a shaping machine during a return stroke. What is the detail of column? That we are using this column, that is almost all the machine bed that is made from a cast iron. It has a guide base for ram and table. That is a guide base for ram and table, and all other parts are mounted on the column. This column are the supporting member of the shaper machine. Now what is the detail of ram? These are the ram. Here is a ram locking nut, and here is a hand wheel for tool motion. So this dimension of ram can be changed. Detail of ram drive. Ram drive is the drive that are used to drive the ram for cutting a return stroke. So generally it is a ball gear, it is a pinion gear, here it is a pinion gear, okay? And that is linkage to the ram. So whenever it is rotating, this gear is rotating, it will slides in horizontal direction. Whenever this gear rotates in clockwise or anti-clockwise, it will slides in this direction. So by complete revolution of one gear, that will be one forward and one return stroke. Now that is the most important part. What is a quick return mechanism? We have already seen in the linkages in mechanism. It is an inversion of single slider mechanism, or we can say a 4-bar mechanism. Okay, it is an inversion of 4-bar mechanism. Here we are using the one type of the quick return mechanism in shaping machine. We know that what is the quick return ratio? What is the quick return ratio? That is time taken by the forward divided by time taken by the return. That could be always greater than 1. So why we are using the quick return in the shaping machine? So the reason is that whenever the forward stroke is going on, during forward stroke only material removal take place. During return stroke there is no material removal. So why we waste the time during the return stroke? Can we put some mechanism that can drive return stroke very fast as compared to the forward stroke? Yes. So that is why we are using the quick return. In quick return, your forward stroke will be slow as compared to the return stroke. And this can be achieved by this mechanism that is known as a crank and slotted bar quick return mechanism. So the shaper cuts only in one stroke, other stroke is idle, cutting stroke is slower than the idle stroke. Angle covered by the crank is more in cutting stroke, hence more time for cutting. Typical values are cutting stroke are generally used for 220 to 140 and return stroke rate will be 140. These are the most common used. Okay, these are the most common used. Now ball gear rotates a uniform speed, but ram speed is varying. By changing the length of crank, ram stroke can be changed. You can change the length of this ram and you can change your cutting and forward stroke. What is the cutting velocity? That is almost 2 times of average velocity, because quick return ratio is generally given to the 1.8 to 2 times. So what are the average velocity? We are getting cutting velocity 2 times of average forward velocity, and cutting speed is equal to 2 times of n upon rs, where n is a rotational speed, rs upon stroke ratio. So these are the setting tool. Now how we can set the tool? Okay, what are the right, what are the wrong? So the first thing, tool overhang should be minimum. Tool overhang, it means from this locating the overhanging should be minimum, because during the cutting surface it creates some force and creates some bending towards this point. If your length is more or your overhanging will be more, then there is a more chance of failure of tool. So tool overhang should be low. Tool overhang should be low. Now the second is tool must be clamped. Tool must be clamped properly with adequate support. You must have a proper support for adequate. That is tool overhang. So for designing of that, what we are doing? Please be remember that during the setting of tool, tool overhang should be minimum. Tool should be clamped properly with adequate supports. Now, what are the setting the stroke length? How we can set the stroke length? What should be the length that can be set during a forward and cutting stroke? It should be maximum, it should be minimum, or we can decide according to the workpiece. So the right answer is we have to decide the stroke length according to the whatever the length of workpiece that we have to cut during the forward stroke. So maximum stroke length depends on the machine, that is 18, 24, 36. That is a standard specification of machine. We have to design the stroke length that is a maximum for this. Stroke length can be adjusted with value less than maximum. It means you cannot go beyond this maximum value. You have to put your stroke length such that your stroke length should be minimum of this maximum. So stroke length depends on the length of job. Suppose your length of job will be this. Okay, so you decide the stroke length such that there is some clearance at starting and there is some stroke at after of the cut. So that is a proper standard for setting the stroke length. Now What are the setting the position of stroke? Where we can start our stroke, where we can end our stroke. So that is a, we can say that correct length of rem stroke, correct position of rem stroke. ये जो हमारी correct length है, that is the correct length of a stroke. It means this much amount of stroke that is needed for cutting this workpiece, but it is not a correct position of stroke, because if we cut in this direction, it will cut only up to the here. This material will be left out. So for cutting action, this stroke length can be adjusted in such a way that it can cut all the workpiece. So we have to provide some clearance, some stroke at here at the beginning and some stroke at the afterward. Now, what are the position of workpiece? How we can locate the position? Okay, suppose if you want to cut in this direction material, so here it is your tool, so you have to locate the workpiece in this direction. So in this direction the material removal take place during the forward stroke, and there is no material removal during the return stroke. If you want to cut material in this direction, you have to locate the workpiece on a vise in this direction, so it will cut, and during each cut your material will be rotated. Now, shaper machines. Steps in making a block square parallel. If you want to make this box parallel and square, what are the different steps? So for that, what are the steps in making a block square and parallel? So first thing is remove all the dirts and burst. Remove all the dirts and burst. Suppose it means your workpiece must be clear. Cleaning that is must first precaution during loading of the workpiece. Vise jaw should be perpendicular to the line of motion. Your vise jaws must be perpendicular to the line motion of motion. Tool that must be vertical. Set the workpiece in a vise with parallel blocks at the bottom. Workpiece that must be set in vise parallel to the block. It means there is no any tilted of the workpiece. All cutting force should be against the fixed jaw of vise. And machine the slide 1, it is a surface having the largest area, and machine side 2 with side 1 resting against the fixed jaw. That is a location of the surfaces. And machining of a block. Suppose if you want to perform machining of some block, that is your workpiece. Okay, so how you mount the workpiece? So for that, there is a solid jaw, that is a movable jaw. Okay, step 1, just you insert some parallel keys so that it can be mounted. Or suppose your vise is not adjustable, put some metal rod for tight grip. Step 1. Step 2, put some metal rod. Then step 3, 3, 1, 2, and then again locate this whatever. That is step 4. Now these are the some important parameter as well as some important machining, how we can perform a machining by the use of tool, shaping machine. So shaping machine, we know all that that is generally used for making of flat surfaces. So flat surfaces can be any particular applications. So it is a machining of chuck key. How you can make a chuck key? During a lathe turning operation, you just see this type of chuck key. Okay, so if you want to make this chuck key, just locate this in the vise and you put your tool in such way that it can cut in this direction, then reposition this tool, cut in this direction, reposition, cut in this direction, and cut in this direction. By cutting this all the phases, you can make your chuck. Okay, what is the second? Making a V block. Suppose if you want to make a V block, so for making a V block, we know that a V block is always at some angle. So to obtain that angle, your tool must be at some particular angle. So you have to tilt your tool to the angle at which we want a V block. At which angle we want a V block. Now to want that V block, here your tool will be tilted, and during a machining, at each machining there will be a generation of this flat surface, but it will be at inclined. And during this slot cutting, you have to make a tool perpendicular to the cut, make some cut, and again tilt the tool in this direction, it will cut in this way. So tool slide is tilted at an angle for a V block. So how to make a V-block? It doesn't mean that shaping machine always use for a square bar. That is why my workpiece must be square. You want to produce a flat surface at any angle, you can produce by using a shaping machine. Okay. Now making an external keyway. Suppose you want to mount a keyway, that is known as here. If you look at here, that is a keyway. Okay, that is the one type of slot. Slotting that is generally performed on the milling machine. But if you want to make a slot by using a shaping machine, suppose you have only shaping machine, you don't have a milling machine. If you want to cut a one slot for keyway, okay, so you can make by using this shaping machine. How? So you have to just use this type of tool and you have to insert this tool and cut in these directions, okay, and you can make your slot. Bow at all. Now you can see this type of workpiece in your lathe machine. This is known as a dowel. Okay, so to make this dowel, again same as a V-block, you have to tilt your tool at some required angle, such angle that is required in this dowel. So first of all, you must know about what are the angle required in this dowel, and same angle you have to tilt this tool and the cutting take place in this dowel. Okay, so we want to make out the gear by using this shaping. How we can make? It is a pictorial view that how we can make a gear. It is a one type of rack and pinion. It means the reciprocating rotary motion can be converted into the linear motion. So it is the making of rack. So if you want to make a rack, use a tool such that this will be some profile. It means when this tool is inserted completely up to depth of cut, it will generate some profile on that particular workpiece, and that will be your one teeth. After cutting a one teeth, you just slide this rack in any one of the direction, you will get a second teeth. After the completion of second teeth, third, fourth, up to n. So you can make your rack by using a shaper. These are some typical applications where we can use a shaping machine. Now somehow workpiece with marking. Suppose if you want to make this type of profile, okay, you can make by using these machines. Yes, absolutely. How? So first of all, you have to mark the workpiece which profile that you want, and you can perform a cutting. It means suppose this dimension is 2 mm. Okay, so take a cut up to 0.5 mm up to 4 times, it will be cut. Then slide this machine, measure this distance, set a cut. Suppose it is a 2.5 mm, set a 5 cut of 0.5 mm, you can make. And after machining up very precisely, you will get this equation. But the accuracy that is generated by this shaping machine, that is a very less as compared to the right now non-conventional machining, that is EDMECM. Okay, but we can make it by using this shaper machine of machining of contour. If you want any profile, you can make it by using the shaping machine. Okay. Now what is a different specification? Now if you go to the market and if you know that and you tell that I want to buy a shaper machine, so they will give you one catalog. In that catalog, these are the details that must be written. These are the details. How can you identify that which shaper machine that you want? The first thing about the length of ram stroke. How much of maximum length of ram stroke? That ram stroke decide the size of component that can be machined on the shaper machine. Suppose it is a 457 mm, it means it is 18 inch. Okay, 1 inch is 25.4 mm. So length of ram stroke that decide the size of component that can be machined, and a range of ram speed. How much amount of range is available for ram speed? It means 12, 24, 14, 72 strokes per minute. These are the different ram speed by okay, by changing the speed of the gears. Working surface, how much amount of working surface is available. Maximum table travel, how much amount of maximum travel in horizontal as well as in vertical. These all the parameters decide the size of the workpiece that can be machined. Angular movement of table, that is 60 degree. Maximum size of tool strength on tool head, it means how much amount of tool that can be mounted on tool head. That is 51 mm to 21 mm. Maximum vertical tower of tool strength, how much amount of tool that can be traveled in a vertical direction, that is 150 mm, 152 mm. Maximum swivel of tool head, how much degree that your tool head can be swivel, that is 60 degree. So these are the some specification of shaper machine. You can go this shaper machine specification, and if you know about the each and every particular thing, then you can buy this shaper machine very accurate and precisely as per your need. Okay. Now planning machine. Suppose you are mounting a two workpiece, two tool. Okay, and here in shaping machine your tool is rotating, tool is reciprocating, and your workpiece is stationary. But if I make it a reverse, suppose my tool are stationary while cutting, and the feed is given to the feed is given after completing of one stroke, and table reciprocates. So that type of machine is planning machine. Now the question comes, that's why we want a planning machine, as we have already know the shaping machine. So what are the different things, or what are the different features that we can make using a planning machine as compared to the shaping machine, or what are the different advantages of planning machine as compared to the shaping machine? So for that, suppose your workpiece size is very large. If your workpiece size is very large, you cannot mount on a shaping machine, because the workpiece size is limited in the shaping machine, as we have discussed about the working surface table. There is a limitation. Okay, so for that, these are the tables. We can reciprocate these tables towards the tool. Here our tool will be stationary. Okay, so for that we are using this planning machine. So it is generally used for the larger jobs, and somehow it is less accurate as compared to the shaping machine. So it has some introduction to planning machine. So what is a shaping machine? Shaping machine, it means tool reciprocates, your workpiece will be stationary. What is a planning machine? It means tool is stationary, your workpiece will be rotated. What is a slotting machine? So slotting machine, what is a slotting machine? Slotting machine is the one in which your ram would be in vertical, and in shaping machine your ram should be in horizontal. So these are the some introduction to the shaping machine. You can go through that. Now as I discuss about the important topics from the shaping machine, these are the what are the use of principle of shaping machine, what are the different types of shaping machine, then what are the use of clapper box, why we are using the clapper box, then quick return mechanism. Okay, specification. Suppose the question should be like this: write down the specification of shaper machine. What are the different features that can be included in the shaping machine? So these are also important. This can be helpful. Okay, and what is the difference between shaping, planning, and slotting machine? Okay, so these are some introduction of shaping machine. Okay, thank you.